Mr. Klein here from Klein Maths. Today we're going to do the Higher Maths Essential Skills 2025 exam paper. This is around 50 minutes long, 55 marks. Can't use a calculator. And yeah, marks are a bit harsh on this one. But Mr. Rennie made this one, so we'll just go with it. I think some of you all found this hard, so hopefully just give it a go. And just a reminder, if you are finding things tough at the moment, Higher Maths Last Minute Exam Prep stream on the Sunday the 11th of May at 6 p.m. for YouTube members only. Join now, it's only £4.99. Clever Maths is sponsored by Lecky, the educational publisher for Scotland. Today we're going to look at practice workbooks for National 5 and Higher Maths. These are just £5.59 when you use the discount code CleverMaths at leckyscotland.co.uk, and these are excellent because they have lots of questions topic by topic by topic. So as you're working through the year, you can revise and practice any topic you want and make sure you are comfortable with that topic. But also when it gets towards exam season, a practice exam paper right at the end to make sure you're ready for your exams. Just £5.59 when you use the discount code CleverMaths. The links are in the description and down below. Let's do a Higher Maths 2025 Essential Skills Paper 1 Question 1. Determine an equation of a line perpendicular to 3x plus 4y minus 5 equals 0, passing through the point 2 minus 3. So perpendicular means I need the perpendicular gradient. So I start off with 3x plus 4y minus 5 equals 0. And I need to rearrange that to make it y equals mx plus c. So leaving the 4y where it is, I get minus 3x when I move it, plus 5, divide by 4, minus 3 over 4x, plus 5 quarters. So the gradient of y is equal to minus 3 quarters. So we can say straight away that the gradient of the perpendicular, which I can just draw a wee right angle, is equal to the negative reciprocal. So we flip it upside down and we change the sign. So that's just 4/3. And we need to write y since m1 times m2 equals minus 1. Always remember that little statement when you use perpendicular gradients. And then it says we've got a gradient now. Great. And we're passing through the point 2 minus 3. So it's just y minus b is mx minus a. Where a and b are 2 and minus 3. So y minus minus 3, watching our signs, equals 4/3. X minus 2, and since I've got a fraction, I will just get rid of the fraction by taking the 3 up to the other side. Y minus minus 3 becomes plus 3, and then I've got 4x minus 2. That's 3y plus 9 then, 4x minus 8, and you can leave it in any way you want. You can leave it as y equals, or you can just rearrange it so it's got y and x on one side and a number on the other side, or yx and a number on one side and 0 on the other side. So I'll move everything to the left-hand side. Minus 4x plus 3y. 9 minus 8 becomes plus 8. Plus 17 equals 0. That's one way to leave it. Or you could leave it as minus 4x plus 3y equals minus 17. Or if you really wanted to have it as y equals, well, I'll have 4 over 3x minus 17 over 3. Anyway, any of them are fine. SQA Higher Maths 2025 Essential Skills Paper 1 Question 2. A function is defined by f of x is 7 minus 3x over 2. Find the inverse function. I'll give you two ways to do this. The standard way that a lot of teachers teach is to say that we've got y equals 7 minus 3x over 2, and you rearrange for x. So that means that you've got 2y is 7 minus 3x. Taking away 7 then, 2y minus 7 equals minus 3x. It's a 3. And then divide by minus 3. 2y minus 7 over minus 3 equals x. Can't really leave it like that. So I'll leave it as x equals minus 2y plus 7 over 3. And then straight away you can say that the inverse function of x is equal to minus 2x plus 7 over 3. So if you use this method, just make sure that when you go from here to here, you never switch it back to say y equals again, because then you're saying that two things are equal to y, which it isn't. So go from x and then just say the inverse function equals and swap the y at x at that point. I'll show you another method of what you might like. F of x is 7 minus 3x over 2. So I'll show you an alternative method of this that you might like. F of x is 7 minus 3x over 2, I think it was. Yep. And you should know, hopefully, that if you take a function and then put its inverse in, f of inverse of x, you always get x back. So that means that I can just do a composite function here and sub in that for x and then solve for the inverse. So that means that I've got 7 minus 3 inverse function of x over 2 equals x. I'll just make the inverse function the subject. So I've got 7 minus 3 inverse function equals 2x. So minus 3 inverse function equals 2x minus 7. So the inverse function is 2x minus 7 over minus 3, but we don't want a minus on the bottom, so we just put it to the top, minus 2x plus 7, because a minus divided by minus is a plus, over 3, and we're done there. SQA Higher Maths 2025, Essential Skills Paper 1 Question 3. A sequence is generated by un plus 1 equals 3/4 un minus 5, and it tells us that u3 is minus 2. We'll have to work out the value of u1. Okay, so if we're going to do that, we're going to have to do it a bit at a time. So I know u3, so I can probably get to u2. So for part A, u3 equals 3/4 u2 minus 5, but u3 we know is minus 2. So rearranging that, we get 3/4 u2 equals minus 2 plus 5, which is 3, times them by 4 then, 3u2 equals 12, so u2 equals 12 divided by 3, which is 4. So now we can work out u1, because we know that u2 equals 3/4 u1 minus 5, but u2 is 4. So 3/4 u1 equals 9, 4 plus 5. 9 times 4 is 36, so 3u1 is 36. So u1, 36, divided by 3 is 12, and we're done there. It says the sequence approaches a limit as n goes to infinity. Determine the limit of the sequence. It doesn't say, usually when you're doing a limit, you need to say why. It tells you there's a limit, but I'm still going to say why just to be on the safe side. Okay, so I've got for part B, un plus 1 equals 3/4 un minus 5, and I can say that as n goes to infinity, the sequence has a limit as this number in front of un is between minus 1 and 1. Minus 1 is less than 3/4, which is less than 1. So that's my statement for why there's a limit. So then I sub it into the limit formula, which you hopefully know is b over 1 minus a. There is other ways to do this, but this is the simplest way, where b is minus 5 and a is 3/4. So that's minus 5 over 1 minus 3/4. That's minus 5 over 1/4, which is the same as minus 5 times 4 over 1. Or in other words, minus 20. And we're done there. SQA Higher Maths 2025 Essential Skills Paper 1 Question 4. Functions f of x, 2x minus 1, g of x, 3 over x squared are defined on suitable domains. Find an expression for h of x, which is g of f of x, a composite function. So h of x, g of f of x means every time in g I see an x, I put f of x. So if I write that out, that's 3 over f of x all squared. Well, f of x is 2x minus 1. So 3 over 2x minus 1 squared would be a suitable answer. Now that's actually already simplified. Determine any restriction on h of x. Well, h of x is 3 over 2x minus 1 squared. You can never divide by 0. So when is that 0? We'll just do a bit of work outside. 2x minus 1 squared equals 0, means that 2x minus 1 equals 0, means that 2x equals 1, means that x equals a half. So x equals a half you can never have. So x can never equal 1/2 is the restriction on the domain. SQA Higher Maths 2025 Essential Skills Paper 1 Question 5. For the polynomial 2x cubed plus px squared plus qx plus 3, x minus 3 is a factor, and minus 25 is the remainder when x plus 2 is divided by it. SQA Higher Maths 2025 Essential Skills Paper 1 Question 5. For a polynomial 2x cubed plus px squared plus qx plus 3, x minus 3 is a factor, and minus 25 is the remainder when it is divided by x plus 2. Determine the values of p and q. Okay, so this is going to be simultaneous equation. Now, I'm going to put my factor in a way that most schools would do it, which is synthetic division. So for part A, there is other ways like long division, but I'm going to do it the normal way. X minus 3 is a factor, so I can put 3 on the outside. You could also just sub in directly. You get 2, P, Q, and 3. I drop the 2 down. 2 times 3 is 6. Add 6 plus 3. I times by 3, that's 18 plus 3p. I add, which is 18 plus 3p plus q. And then I times 3 18s, I'm running out of space. 54. 3 3s is 9p plus 3q, not missing anything. And then I add, so I get finally 54 plus 9p plus 3q. Well, it's plus 3, so I was going to write plus 3, but I like 57, I think. There we go. X minus 3 is a factor. Therefore, remainder equals 0. So we get 57 plus 9p plus 3q equals 0. Or to write that nicer, 9p plus 3q equals minus 57. There's one equation. So our second condition says that minus 21 is a factor when divided by x plus 2, so I can just do this again. So setting up my synthetic division, x plus 2 means I've got minus 2 on the outside. I've still got 2pq3. 2 2's is 4, but it's minus 4. Minus 4 plus p. Watch your minuses here. 2 times 2 is 4, but it's 2 times 4 is 8, but it's positive 8, and then minus 2p. 8 minus 2p plus q, and then finally minus 16 plus 4p minus 2q to get minus 16 plus 3 is minus 13 plus 4p minus 2q. And then the remainder, I'll just call it r, was minus 25. Therefore, minus 13 plus 4p minus 2q equals minus 25. Or 4p minus 2q equals minus 25 plus 13 is minus 12. So we've got two equations now that we can solve simultaneously. The first one, 9p plus 3q is minus 57. And the second one, 4p minus 2q equals minus 12. So we've got our two equations. You could just scale them up by times them by 3 and times them by 2, but a neater way to do it actually is, if you realise that 3 goes into all of that, you could divide that by 3, and that 2 goes into all that, divide that by 2, just to get simple equations and easier numbers to play with. So I'm going to do it that way just for a change. Divide by 3, divide by 2, but it's just simultaneous equations. Hopefully you're fine with this. 3p plus q equals minus 19, and 2p minus q equals minus 6. I can now add these because the signs are different to get 5p equals minus 25. So p is minus 5. And then sub into any equation I want. So I'll just sub into this one. 3 times minus 5 is minus 15 plus q equals minus 19. So q is minus 19 plus 15, which is minus 4. And we're done there. So that's part A done. Part B says, hence solve 2x cubed plus px squared plus qx plus 3 equals 0. Well, we know our p and q now. So for part B, 2x cubed plus px squared, which is minus 5x squared, plus qx minus 4x plus 3 equals 0. Now, we already know from above here that x minus 3 is a factor. You can sub it in again, or you can sub in the p's and q's. It's up to you. I think subbing in again would be much easier. So I'm just going to sub in 3. So I know that my x minus 3 is a factor, so I can just say I've got 2 minus 5 minus 4, 3, and 3, which gives me 2, 6, 6 minus 5 is 1, 3, 3 minus 4 is minus 1, minus 3 and 0 as expected, and therefore remainder equals 0, therefore x minus 3 is a factor. So we get x minus 3, 2x squared plus x minus 1 equals 0. And then we need to check, can we factorize 2x squared plus x minus 1? Well, yes, we can. So just by inspection, it's quite an easy one. I've got 2x and x to get 2x squared. It has to be 1 and 1 to get minus 1. Then just getting the signs around the right way, I'll have 2x minus 1x to get x in the middle. And therefore, x equals 3, x equals a half. Where do I get a half from? Well, I'll take 1 over and divide by 2, and then x equals minus 1, and we're done there. SQA Higher Maths 2025 Essential Skills Paper 1 Question 6. Find the x coordinates of the stationary points on the curve with equation y equals x cubed minus 2x squared plus 1 and determine their nature. Stationary points occur when the y by dx equals 0. Stationary points occur when the y by dx equals 0. You really need to get that statement in. So I'll work out the y by dx. 3 comes down, x, take 1 from the power. 2 2s is 4, take away 1 from the power, so that's just 1, and then the 1 disappears. I'm going to say that equals 0. So that's just common factor of x, so I get 3x minus 4. So that means that x equals 0, or 3x minus 4 equals 0, which gives me x equals to 4 goes over 3. So there's the x coordinates of the stationary points. I now need to determine their nature. So usually a nature table is your best bet for this. Whereas other ways, second derivative, but we're going to go with that. So my nature table, I've got my x and my dy by dx. I'm just saying, look, I'm approaching 0 and approaching, and then I've got another one. I'm approaching 4/3, and then approaching away. So you can just pick numbers in the vicinity or close to 0 and close to 4/3. So a good one would maybe be minus 1 and 1 on that side. And for this one, just before 4/3, well, that would be 1, and then maybe 2. So subbing it in, it's factorised is probably easier to work with. If I put minus 1 in here, I get minus 1. 3 times minus 1 is minus 3, minus 4 is minus 7. Minus 7 times minus 1 is 7, so that's positive. If I put 0 in, I get 0, of course. And then if I put 1 in, I've got 3 1s is 3 minus 4, which is minus 1. Minus 1 times 1 is minus 1. That's negative. Feel free to take your time on these. Now, I've already done 1, so shouldn't we have a little x here again? Don't need that, just approaching. So at 1, we already know it's negative. We know it's 0. 2, I'd imagine is going to be positive, but let's just check. 3 2s is 6, minus 4 is 2, that's positive. Times positive 2 is still positive. So our shape is along, up, along and down, down, along and up. Notice I do my stationary points separately. Quite a good habit to get into in case there's something weird happening between these numbers. Okay, so then we can just say that x equals 0 is a max turning point. X equals 4/3 is a min turning point. And if we needed to find the coordinates, you would sub both the 0 and the 4/3 back into the original y, but it doesn't ask us to do that here. So we're done there. SQA Higher Maths 2025 Essential Skills Paper 1, Question 7. Show that tan x cos cubed x is equal to sin x minus sin cubed x. So it's a trig identity here. I see a tan, I don't see a tan on the right, so I can immediately write that tan x is sin x over cos x, and that's times by cos cubed x. Well, that eliminates a cos from the bottom and a cos from the top to give sin x cos squared x. Now, there's no cos's on my right-hand side, but sin squared x plus cos squared x equals 1. So I can rearrange that to get cos squared x is 1 minus sin squared x and sub it in. So that equals sin x 1 minus sin squared x. Expanding that out, you get sine x minus sine cubed x, which is what I want us to have. So we're done there. Part B says, given that f of x is 2 tan x cos cubed x, find f dash pi over 3. So it's two lots of the original thing, so I can rewrite my f of x as just 2 sine x minus 2 sine cubed x, and just differentiate that instead, because we don't know how to differentiate tan x cos cubed x until advanced higher maths. F dash x. Start of exam paper tells you that sine goes to cos. So I've got 2 cos x for the first one. Now watch out for this next one. This next one, I prefer to write as minus 2, I'll put it in black, minus 2 sine x cubed, to remind me that when I differentiate it, I'm using the chain rule. So the 3 comes down to the bottom, which is minus 6. Take 1 away from the power to get sine squared x, or sine of x all squared. But then I need to times by the sine x differentiated, which is cos x. So this is a hard chain rule one. So that finally gives me 2 cos x minus 6 sine squared x cos x. You can factorize it if you want. I think it might be useful to do so, but I'm not going to. I'm just going to. I think most of you won't bother. So I'll show you it factorized, but you can leave it the way it was. 2, I can take the 2 out actually, to just get 1 minus 3 sine squared x. So you could have it like that if you want, or like that. But now we have to sub in pi over 3. So f dash pi over 3, I'll sub it into the original. So I've got 2 cos pi over 3 minus 6 sine squared pi over 3 cos pi over 3. Well, these are exact values. We're in a non-calculator paper here. So remember your triangles. 1, 2, 3, that gets a root. And that's the 60-30 triangle. 60 degrees, 30 degrees. Changing that to pi's, 60 is 180 divided by 3, so that's the pi over 3 one. So that gives us 2 cos of 60 is a half, 1 over 2. So 2 times a half, minus 6 times the sine of 60 is root 3 over 2. But remember that's squared. Cos of 60 is still a half. So we get all that, and we need to simplify that. So 2 times a half is 1. Minus 6 root 3 squared is 3. 2 2's is 4 times a half. Finally, that's 1. 6 4's is 20. 6 divided by 6 times 3 is 18 over 4 times a half. 1 minus, well, I can simplify that to 9 and 1. 9 quarters. Finally, 1 is 4 quarters. 4 minus 9 is minus 5 quarters. So we get minus 5 quarters, and we're done there. SBA Higher Maths 2025 Essential Skills Paper 1 Question 8. Show that the line with equation x plus 2y plus 14 is a tangent to the circle with centre C in equation x squared plus y squared minus 6x minus 4y minus 32 equals 0, and find the coordinates of the point of contact P. It says relative to a suitable, not spelled correctly, set of axes, the diagram shows a circle from A with a smaller circle centre S. The line is a common tangent at point P. The radius is 1/3 the size of a circle C. Find the equation of a small circle. Right, we'll do A and then get to B. So A is show that something is a tangent. So let's write down our equations first of all for A. X plus 2y plus 14 equals 0. And the circle's equation is x squared plus y squared plus 6x minus 4y minus 32. Okay, so if this is a tangent to that, that means that if I solve them simultaneously, I'll only get one answer, one point of contact. If I get more than one answer, it's not a tangent. If I get no answers at all, no real roots, it's not even touching it. So that's your goal. So your best bet when you're doing simultaneous equations with something with squares and something not squares is rearrange the linear one, the one with no squares, and make x or y the subject, and then sub it in to that one. So that's going to be my approach. So looking at this equation, I'm just going to make x a subject because it's already a single x, is minus 2y minus 14, moving it over. So subbing it in, that gives me x squared plus y squared plus 6 times x minus 4 times y minus 32 equals 0. So now we need to expand all our brackets. So to expand a square bracket, you can square the first term to get 4y squared. You can then times them together. 2 14s is 28. And then double it, 56. So that gives me 56y, and it's positive. So minus is a minus is a plus. And then 14 squared, just do it at the side if you want, or if you can do it in your head. But I'm going to try and do it in my head. 4 4s is 16. 1 times 4 is 4 times 2 is 8. I think that's 186. That should be 196 because of the 16. And then I've got plus y squared. And then I've got minus 6 2s is 12y. And then I've got 6 times 14. Well, 6 4s is 24. 6 1s is 6, 7, 8. And I've still got minus 4y minus 32 equals 0. So collecting all the terms, I've got 5y squareds. And then I've got 56y minus 12y minus 4y. Well, that's minus 16y, so that makes 40. And then I've got my number parts. 196 minus 84 minus 32. Well, let's put that together. 84, 85, 86, 96, 06, 16. 116 I have to take away. So that's 26, 36, 46, 56, 66, 76, 86, 96, 80. So it's 80. And that all equals 0. Well, 5 is a common factor. And now I need to show that that only has one solution. We'll just solve it. Or you could use the discriminant if you want to, but I think solving it's just the simplest method. Double brackets. It's going to be the same bracket if it's got one solution. So I'm looking for two numbers at times to make 10, but add to make 8. So 5 is a common factor. To get y squared, 5 8s is 40, and 5 16s is 80. And now I need to show that there's only one solution, so I can just solve it. Y and y, two numbers at times to make 16, but add to make 8. Well, I want them to be the same number anyway. It's 4 and 4, plus and plus. So therefore, it's a repeated root, so it's only one solution. So y equals minus 4. And therefore, we can work out x now. X is minus 2y minus 14, remember. So x equals minus 2 times minus 4 is 8, minus 14. 8 minus 14 is minus 6. One solution, repeated root. Therefore, x plus 2y plus 14 equals 0 is a tangent. And then the point of contact, which is called P, which is worked out, P is minus 6 minus 4. And we're done there. Okay, let's look at part B. Relative to a simple set of axes, the diagram shows a circle from A with a small circle centre S. So we know P already is minus 6 minus 4. We'll just take a note of that here so we don't get lose track. The line x plus 2y plus 14 is shown as a common point to P. The radius is 1/3 the size of a circle centre C. We'll find the equation of a small circle. We better take a note of the original equation then. So there's our original equation there of our big circle. So we can work out the radius of that circle because we've got the equations. So from the start of the exam paper, This is expanded form. There's two forms. You've got x minus a squared plus y minus b squared equals r squared, or you've got this form. And in this form, your centre is minus g minus f, where that divided by 2, that's 2g and 2f. And your radius, I always remember it as the centre squared minus the other number. So it's g squared plus f squared minus c. So for this question, the radius of a big circle, the radius c, is the square root of, well, what is my g? 6 divided by 2 is 3. And then 4 divided by 2 is 2. Minus 32. So that is 9 plus 4 plus 32. 32, 33, 34, 35, 36, 47. 45. 45. Check that again, 32, 41, 45. Now, that's a surd, it's not square rootable, but we'll leave it as a simplified surd just for the sake of completeness. Always simplify as much as you can. That's 9 and 5, which is 3 root 5. And why would you want to do that anyway? Well, it tells you the radius of the other circle is a third of it. Couldn't really do a third of root 45, but I can do a third of root 3 root 5, so that's handy. So we now know the radius of S is a third of 3 root 5, which is root 5. So the only thing to find is the centre, and then we'll have the equation of our circle. So we've got S going along to some P, which is minus 6 minus 4, going along to the centre of our other circle. Well, we know the centre, well, we can work it out, it's minus g minus f, remember. So we know g is 3, so it's minus 3, and that is minus 2, so it's 2. Minus 3, 2. So basically it's a vector question here where we know that S to P, say, and P to C. And we know that 3SP equals 1PC. So that means that we know that 3P minus S equals C minus P. So we can rearrange that, and I'll show you a quicker way in a minute, but just for the sake of fullness, 3P minus 3S equals C minus P. So taking the P over to the other side, we get C minus P minus 3P is minus 4P. So S is equal to C minus 4P all over minus 3. Okay, so S is equal to C, which was minus 3, 2. So it's a minus 3, 2. Take away 4 lots of our P, which is minus 6 minus 4, all divided by minus 3. So that's on the top, 4 6s is 24, minus 3 plus 24 is 21. On the bottom, 2 plus 16 is 18, and that's all we're going to be divided by minus 3. So S is equal to 7, well, minus, and 3 6s is 18. So that means that the point S is minus 7 minus 6, and we know the radius is root 5. So finally, the equation, x plus 7 squared plus y plus 6 squared equals root 5 squared, which is 5, and we're done there. Going back up to here, there is a slightly quicker way to do this using something called the section formula, which you may have been shown. So I'm going to show you that again with this picture here. So the section formula says that usually that P would equal 1 times that plus 3 times that, like a little cross, so 3xy, all over 1 plus 3 is 4. So you could work it out that way, but we already know what P is, which is minus 6 minus 4. So you get minus 3 plus 3x, 2 plus 3y, all divided by 4. That gives you minus 6 minus 4 is equal to minus 3 plus 3x over 4 for one of them, and 2 plus 3y over 4 for the other one. So that gives us two equations. Minus 3 plus 3x over 4 equals minus 6, or 2 plus 3y over 4 equals minus 4. Solving both of them, minus 3 plus 3x equals minus 24. 3x is minus 21 then, so x is minus 7. Or 2 plus 3y equals minus 16. Taking away the 2, 3y is minus 18, so y is minus 3. And that gives us our x and our y, and then we would follow on from what we did before. SQA Higher Maths 2025 Essential Skills Paper 1 Question 9. Vectors A, B and C are shown in the diagram. Angle QTS is pi over 4. The size of A is 4 root 2 and the size of B is 6. Calculate A dot B plus C. So I need A dot B plus A dot C. So A dot B is easy enough because I've already got a vector and then another vector going out and then the angle in between. So that's just the size of A, the size of B, times the cos theta, plus the size of A times the size of B, C, times the cos of some other angle. Let's just call it, I'll just call it theta again, but it'll be a different one. I'll call it theta dot. Okay, so the first one's easy. That's 4 root 2 times 6 times cos pi over 4. It's the other one that causes issues, because we don't know the size of C. But there's ways to do it. If I draw a line down here, then I can find the length of that line, which is the size of C. So that's fair enough. So if I do that at the side, we've got a right angle triangle, I've got pi over 4, I've got A on the hypotenuse, which is 4 root 2, and we're going to call that C. So sine pi over 4 equals C over 4 root 2. So C is sine pi over 4 times 4 root 2. So what is sine pi over 4? An exact value. Pi over 4 is 45 degrees. So that's a 112 triangle, or root 2. So it's 1 over root 2. So it's 1 over root 2 times 4 over root 2. Root 2 is cancelled to leave just 4. So the size of C is 4. Great. What about the angle in between? Well, remember the vectors need to be drawn. Start your first vector and then another one going away from it. So if I draw down here, there's my A. My C needs to go straight from that origin point. So what is this angle is what I'm asking. Well, let's relate it to here. If I drew C there, then this angle between A and C would be 90 plus pi over 4. So 90 is pi over 2. So that's pi over 2 plus pi over 4, which is 2 pi over 4, 3 pi over 4. So there's my angle. So I've now got plus the size of A, which was 4 root 2, times the size of C, which is 4, times the cos of 3 pi over 4. So how do we resolve that? Well, let's have a look. We already know the cos of pi over 4 is 1 over root 2. So that's 4 root 2 times 6 times 1 over root 2 plus 4 root 2 times 4 times, well, what's the cos of 3 pi over 4? Cast diagram will help here. If you're not sure what 3 pi over 4 is, just change it back into degrees. It's 90 plus 45, which is 135. So if you think I've got 45 here, 180 minus 45 gives you 135, which is in this quadrant, which is positive for sine, but not for cos, it's negative. So that means that it's the same as the cos of 45, but the negative of it. So it's minus 1 over root 2. So finally, my answer, if I just copy that down, I've got 4 root 2 times 6 times 1 over root 2 plus 4 root 2 times 4 times minus 1 over root 2. Root 2's cancel from here to give 6 fours is 24. The root 2's cancel from here to give 4 fours is 16 times minus 1 is minus 16 to give 8 in total. And we're done there. SQA Higher Maths 2025 Essential Skills Paper 1 Question 10. In the diagram, angle CAB equals angle EAC. In other words, the little x. By writing DAE in terms of x, find the exact value of sine of DAE. Well, what is DAE? It's this angle here. So I've got x and x. So angle DAE equals, that's a 90-degree angle, minus 2x. 90 minus 2x. So I have to find the sine of that. So I'm wanting the sine of 90 minus 2x. Well, that is just start of exam paper, sine 90 cos 2x minus cos 90 sine 2x. So I'm going to have to work out the sine and cos of 2x. So let's see what I've got. First of all, I've got 5 and 2 on this triangle. 5 5s is 25. 2 2s is 4. That gives you 29. So that's root 29. We can expand cos 2x anyway to get rid of the 2x. So let's just say we've got that. X 25 root 29. Let's work on what we've got. Sine of 90 is 1. So that's cos 2x minus cos of 90. Well, that is 0 times sine 2x. So that's just cos 2x. Well, cos 2x I can expand from the start of the exam paper any way I want. 1 minus 2 sine squared x would be one answer. So I can work out the sine of x. Sine of x is 2 over root 29. 1 minus 2 times 2 over root 29 then, squared, because it's sine squared x. 1 minus 2, 4 over 29s. That's 1 minus 8 over 29. So 29 minus 8 is 21. So I get 21 over 29. And I'm done there. SQA Higher Maths 2025 Essential Skills Paper 1 Question 11. A curve f of x, y equals f of x is such that dy by dx is 6x squared minus 5. The curve has a root at x equal to 1. Express y in terms of x. So it's a differential equation, which means that I can just integrate dy by dx. So y equals the integral of dy by dx, which equals the integral of 6x squared minus 5 dx. So that equals, add 1 to the power, divide by the new power, 6 divided by 3 is 2, minus 5x plus c, because there's no limits. But it does tell us a condition. It says the curve has a root at x equal to 1. What's a root? It means that if you have some sort of curves, roots are when they cross the x-axis. So it crosses at 1, that means y is 0. So the point is x equal 1, y equals 0. So subbing that in, we get 0 equals 2 1 cubes minus 5 1s plus c. So 0 equals 2 minus 5 plus c. 2 minus 5 is minus 3. Therefore, c is 3. And therefore, we've got the answer now. Y is 2x cubed minus 5x plus 3. And we're done there. SQA Higher Maths 2025 Essential Skills Paper 1 Question 12. Given that the equation x squared plus y squared minus 4x plus 2py plus p plus 10 equals 0 as a circle, determine the range of values of p. Right, so remember, for a circle to be a circle, it has to have a centre and a radius. The centre is minus g minus f. And the radius is the square root of g squared plus f squared minus c. So let's look at this and see what g and f are. In front of x is 4x, which is 2g. So I divide that to get minus 2. And in front of y is 2p. So f is equal to just p, because I divide it by 2. And our c is what's on the end, which is p plus 10. So for that to be a circle, I need to be able to square root something. So I need this g squared plus f squared minus c to be bigger than or equal to 0. In fact, I have to be bigger than 0. If it was 0, then it'd be a point, wouldn't I? It wouldn't have a radius. So that I need g squared plus f squared minus c to be bigger than 0. So g, we've already said is minus 2, plus p squared minus, but a bracket here, p plus 10 is greater than 0. So we've actually made a quadratic inequality. So that's 4 plus p squared minus p minus 10 is greater than 0, or p squared minus p minus 10 add 4 is minus 6. Now to solve a quadratic inequality is very similar to when it's equal to 0. First thing I do is find the roots. So I assume it's 0 for roots. Now hopefully that is factorizable. P and P, 3 and 2, minus 3 plus 2 is minus 1. So P is minus 2 is a root and P is 3 is a root. So then we draw a graph to see where it's bigger than 0 or less than 0. Because we've got minus 2 here and 3 here. Positive P squared means it curves down. I don't really care where the turning point is. All I care about now is when is that bigger than 0? Above the x-axis? Well, it's this side and this side. If it was less than 0, I'd be below the x-axis and I'd be stuck in between. So that means that P is less than minus 2 or P is greater than 3. And we're done there. This has been Miss Glenn from Clare Maths. Today we did Higher Maths 2025 Essential Skills Paper 1. Hopefully you found it useful. Quite a tough little paper actually. I'll get back to you with Essential Skills Paper 2 soon. But if you're liking this content, consider joining the channel. £4.99 for an exclusive live stream the night before the exam. Take care, stay safe, and goodbye.